For the following examples, we're going to use a standard deck of cards as well as a six-sided die. We're also going to use a random sample bag of M&Ms, which was sorted into this frequency distribution table by color. I've also spent some time and added up the total number of M&Ms in this bag, since we're going to need that later on. The total number is 23. And we're also going to use a game called Left, Right, Center. So for the rules of this game, each individual die has one side that is labeled left, one side labeled right, another that is labeled by center, and then three sides with a dot. You play 3 dies at a time on each roll, and you have 3 chips, one for each die. So you lose a chip if you roll anything that says left, right, or center, and you keep a chip if you roll a dot. So for each of the examples below, we want to think about whether it's an independent or dependent event, as well as is it going to be an or an and statement. So for this first example, we're asked to find the probability of rolling a 2, given that a 3 has already been rolled on a regular die. This is considered an independent event because it does not matter what you already rolled on the die. It has no bearing on what you roll next. That being the case, you have 1 out of 6 chance of rolling a 2, or 0.1667. Next, we want to find the probability of selecting a queen, given that a 9 has already been selected in a standard deck of cards. This is going to be dependent, because the fact that we have already pulled a 9 means that we have less cards in the deck to choose from. However, we still have 4 queens left in the deck, out of now the 51 cards left, or 0.0784. Next, we want to find the probability of selecting a green M&M and then a blue M&M. This is again going to be dependent. The fact that I've already pulled a green M&M means I've eaten one, and there's one less in the bag to pull. We're still going to use the multiplication rule. So for the probability of a green M&M, we have 4 out of 23. But the probability of a blue M&M is now the 6 remaining in the bag out of the 22 left. We now want to find the probability of selecting a red card and a brown M&M. This, of course, is independent. When I'm playing cards like poker, it doesn't matter what cards I'm pulling and how I'm eating the M&Ms. The color of the M&M that I eat has nothing to do with the color of the card that I'm playing. Thus, with 26 out of 52 red cards and 3 out of 23 brown M&Ms, our probability is 0.0652. For our next example, we want to find the probability of rolling a 1, then 2, then 3, then 4 on a regular die. Again, think about taking a die in a game and just rolling it over and over again. The probability of one has no bearing on the probability of another. That makes these independent events. Individually, the probability of each is 1 out of 6. We can write this as 1/6 raised to the 4th power. Notice how my calculator says 7.716 e to the negative 4. That e to the negative 4 means that my decimal point should actually be 4 places to the left. So the negative indicates the directionality of where the decimal point should be, and the number here indicates how many spaces. If I take the time to move the decimal point 4 places to the left and put zeros in the place values that I have now utilized, I can actually see the expanded form of what the true decimal of this probability is and round that to 4 decimal places, which is 0.0008. In the next example, we're playing the game Left, Right, Center. We want to find the probability that we're going to lose all chips on the first roll. Since we are rolling 3 individual dies, the probabilities are going to be independent. Of the 6 sides on the die, we will lose a chip if we roll a left, a right, or a center. So our probability of losing a chip on each individual die will be 3 out of 6. I can then write that as 3 out of 6 raised to the 3rd power, or 0.1250. Lastly, I want to find the probability of rolling a 6 or selecting a club. This is also independent because rolling a die and selecting cards has nothing to do with each other. Since this is an or statement, the probability of rolling a 6 is 1/6, plus the probability of selecting a club as being 13 out of 52 is equal to 0.4167. You don't need to worry about cutting common denominators, just putting these into your calculator and letting that do all of the work for you.